Hello. So today we are going to do a problem on inequality. Okay. So the question states like when you have x plus 1 over x is always greater than or equal to 2, you have to prove this. Okay. Now I have already done this problem in my class with students. However, the same problem can be done in various different ways. It can also be written a bit differently, and then based on that you can get several variations of the same problem. And as I have said already, that the TMUA never talks about something really advanced. Okay, so they will not go out of syllabus for the most part, maybe one or two problems which are become simpler with more advanced concepts. Okay, but they mostly like to play around with the basics. Okay, and so we should do the same thing and then try to see the variations of the same problem in a way that actually forces us to, use more tools, try to think harder about the same thing. Okay, so let's start with this. So first of all, we know when x is a positive, this is a basic information that you should have, that arithmetic mean is greater than or equal to geometric mean. Okay, so we will be doing the same problem in various ways. So first is the method 1, which uses arithmetic and geometric mean. Okay, so what is the arithmetic mean? Which is x plus 1 over x over 2 is greater than equal to geometric mean, which is x multiplied by 1 over x. So this gives me x plus 1 over x is what? Is greater than equal to 2 root 1. Okay, and of course in case I didn't say it before, or I said it, but of course as the video progresses we forget, x is greater than equal to 0, greater than 0, not equal to 0. Okay, so that gives you x plus 1 over x is greater than equal to 2. So that was our method 1. Okay, now let's do the same but a method 2. Okay, and that one is, well, the maximum minima method that we use to find at least the critical point. Okay, so we try to do that. Okay, and we use the differentiation here. Okay, because I'm trying to find the critical point. Okay, so that I can see where I have the equality. I want to find the equality case, right? So I have x plus 1 over x with x greater than 0. Okay, so let's differentiate it. I get 1 minus 1 over x square. I put it equal to 0. I get 1 equals to x square. But since x is greater than 0, so we will have x equals to 1 is the only critical point that is permissible to us. Okay, and that gives me what? 1 plus 1 over 1 equals to 2. Okay, so this is, let's see, now we don't know whether it's a maxima or a minima. Okay, so to do that, we do the second derivative, right? And the second, if I write f of x as x plus 1 over x, the second derivative gives me what? It gives me plus 1 over 1 times 2 over x cubed. Oh, at x equals to 1, it is a positive number. That means it is my minima. Okay, so that actually gives you the idea that that means x plus 1 over x is always greater than equal to 2. So that is another method. Okay, now we'll do a third method, which is probably not something that many of you would like or would be very keen on. But if there are some of you, it's especially for those students who are preparing for math or for Olympiads, etc. Okay, what we are going to do here is that we are going to have, let's see, it's called, now we are going to do the method 3. Okay, and this one is called squaring method. Okay, the thing is that we can obtain this inequality if we start from another equation. Okay, and the thing is why it's confusing for many of you is that you'll be like, oh, but in this case I am telling you what we are starting with, but in general if I come across such a problem, I will have a hard time thinking about what equation to start with or what inequality to start with to arrive at the question that is being asked. That's why I understand it's a bit challenging and more of confusing for many of you. Okay, but it's easy. Once you know the equation, it's pretty easy. Okay, so what I'm going to do is that I know x minus 1 squared is always greater than or equal to 0, of course, right? It's a squared number, so it's a positive number. If I expand it, I get x squared minus 2x plus 1 greater than or equal to 0. Okay, and that means I can divide it by x. Okay, and I'm keeping my x greater than 0. Okay, I'm saying I'm dividing it only when x is greater than 0. That is the assumption I'm assuming here. Okay, because if I put x equal to 0, in that case, first of all, it's not defined. If I take x less than 0, then the inequality sign will flip. Okay, and I don't want any of those uh, complications here. Okay, and anyway, if I take x less than 0, I will not arrive at the inequality that I'm trying to prove. So what happens then? I get x minus 2 plus 1 over x is greater than or equal to 0. That is just x plus 1 over x is greater than or equal to 2. Okay, so that is what we have. Okay, now so what we have is that we have a minimal situation. Okay, we have found when the minima exist. Okay, and now let's see a very simple application to this. Okay, it's very trivial. Okay, and of course you can also solve it. If you are directly given the question, you will see that the discriminant of the equation is not positive, etc. Okay, so the application is that x plus 1 over x equals to 1 has no real solution. Okay, and yeah, so the thing is that you can be like, oh, I don't need to know all that thing to get here, but the exam is going to be very much care for how fast you can be, and these kind of tricks come really handy when you are practicing a lot of problems. It builds up your speed, which is where I see many of the students lag behind. Okay, all right, now that we have done that, I will leave, as always, I will give a homework. Okay, so my homework question is that you have x plus 4 over x, and you have to prove that this is greater than or equal to 4 when x is less than 0. Okay, use what we did so far, whatever we have used, multiple methods. It's pretty trivial in that sense, so try to use them and see if you can solve this problem using all the method, because it's not sufficient if you are aiming for really 9 out of 9 for TMUA or really good in math and Olympiads, etc. Of course, if you just are aiming for TMUA or maybe some other exam, it's okay if you can use even one method and get to the answer. But if you're aiming for even a very good mark in TMUA, or for other Olympiads, etc., in that case, it is helpful to be able to solve the same problem using all the methods. Okay, all right, all the best. See you next time.